Hi students, good day. My name is Samson Inemeka, aka Igwe. Please, if today is your first time of coming across this channel, you can hit the subscription button and also the bell beside it for more updates on the various videos that will be coming up soon. So today we'll be discussing the types of reaction rates. Types of reaction rates. When we are talking about rate of reaction, our idea there is to know how fast or how slow a reaction can proceed. But there are various ways of measuring how fast or how slow a reaction can proceed. These are the things we'll be looking at today, which are the types of reaction rates. The first one is the initial rate. We also have the instantaneous rate. We have the average rate. These are the three types of reaction rates. The initial rate, the instantaneous rate, the average rate. So when you are measuring the rate of a reaction, it depends on what you want to achieve. Then you can now decide either to use the initial, the instantaneous, or the average rate. The initial rate simply means the rate of reaction measured at the point the reactants are mixed together, at the onset of the reaction. When the reaction is starting, the rate you have measured at that point is the initial rate, which means the change in concentration you have determined the time taken for the reaction. At that point, you mix the reactants together. That is the initial rate. It can be gotten from the graph when you plot a graph of concentration against time. So the initial rate, like I said, is the rate of reaction measured at the moment the reactants are mixed together. That is at the beginning of the reaction. The rate determined at that point is the initial rate. It can be determined from the graph. When the graph of concentration is plotted against time, the intercept at t equal to 0 gives us the initial rate of the reaction. That means at this point, time equal to 0. Once we come to the graph, this particular point that the line intersected with the curve, you draw a line that is at 90 degrees to that point. Whatever you get here, which is change in concentration axis, that is a concentration axis here, divided by the change in time. The change in time is the distance between here and here. You have gotten the rate of the reaction. So the rate of the reaction measured at this point, you are drawing a straight line that is tangential to this curve when time is 0. So the slope or the gradient on that point is what is called the initial rate of the reaction. Then the second one is the instantaneous rate of a reaction. Instant simply means time. You are measuring the rate of the reaction at a particular time. You want to know what happens at each of these time intervals during the course of the reaction. We have 1, 2, 3, 4, 5. So when I want to know what happens at 2 seconds, I'm talking about instantaneous rate. Or what happens at 5 seconds or 6 seconds, instantaneous rate. So to determine instantaneous rate from this graph, maybe instantaneous rate at 3 seconds. I will come to the number 3 here and trace until I hit the curve. Once I get the curve, I will draw a line that is tangential to the curve and get the gradient at that point. The gradient at that point gives me the instantaneous rate at 3. So the instantaneous rate at 3 seconds can be determined with this. The change in the concentration axis, delta C, over change in the time axis, that is delta T. Whatever rate I have here becomes the instantaneous rate at 3 seconds. If I want to know the instantaneous rate at 5 seconds, I can still do the same thing. I will trace the line until I hit the curve. Then I will draw a line that is tangential to this curve so that I can get the gradient at that point. The gradient at this point now gives me the instantaneous rate at 5 seconds. So that is the instantaneous rate. Now the next is the average rate. The average rate of a reaction is the rate measured when the reaction has been completed. So once you study the kinetics from the beginning to the end of the reaction, the rate you get at that point becomes the average rate of the reaction. Like from this curve now, determining the average rate from the graph, We just draw a line from where the reaction started till the point where the reaction ended. This is where the reaction stopped. If you look at this, you are seeing a kind of slope. You can take a slope of this curve. This is like a triangle. So the change in this axis now, which could be 14 minus 0 all over change in the time, 9 minus 0. So whatever I have here is the average rate of the reaction, because it covers from the beginning of the reaction till the end of the reaction. So these are the three ways we can express the rate of reaction, depending on what you want to achieve. If you want to measure what happens when the reaction is beginning, you go for initial rate. If you want to know what happens at each point during the course of the reaction, at each time interval, you go for instantaneous rate. Then the average rate will give you what happens when the reaction has already been completed. And that is the types of reaction rate. Thank you so much. Remember to hit the subscription button and also the bell for more updates. Thank you.